So today we're going to start our second unit. This unit focuses on linear functions, so understanding lines. Today we're going to take a look at a couple components of that. We're going to do a basic review of slope as well as some graphing. You're going to need some notes. I'll try to tell you what things you don't need to write down as we go along here. And you're also going to want a calculator later on. Let's start with slope. You may remember a few things about slope. In general, slope is the steepness of a line. So as it rises or falls on a graph or in a table, it can also be seen as a rate of change. Oftentimes you talk about it as a rate of change in a science class. Most likely you remember it as rise over run, or this handy dandy little formula that you've used over and over in algebra and geometry. Things to remember are that slopes can be positive, negative, zero, as well as undefined. So let's take a look at what a few of those situations look like. These are different types of slopes. Here in example A, this slope starts low on the left-hand side and rises. So this would be a positive slope. Whereas example B is starting high and going down. This is a negative slope. We always read our lines left to right like we do a sentence. Example C here is showing a zero slope. It is a horizontal line. And situation D here is showing a vertical line. This would be undefined slope. So these different situations could be happening depending on how that line looks on a graph as well as the coordinates that you're working with. Now you don't need to write this part down, but you may remember from geometry that there are different types of lines. There are parallel lines. These are lines that are in the same plane that never intersect each other. We often think of them as lines that never ever cross. Okay, perpendicular lines are lines that do intersect, but they intersect in a special way that makes 90 degrees where they cross, or makes those right angles. So if we take a closer look at parallel and perpendicular lines, again, you don't need to write this part down, but if I look at this picture of parallel lines over here on the left, and I were to figure out their slopes, I will choose a nice little point right here, a nice little coordinate on the first line and another nice little coordinate, and if I count the slope, it appears that this line rises up 2 over 1, so the slope would be 2 over 1, and if I do the same thing on the second line, up 2 over 1, it appears that those slopes are in fact the same. This is what makes those lines not ever going to intersect. The fact that they have the same slope means that they will not ever intersect each other. Okay, perpendicular lines, different situation, same idea though. If we look at the first line, and I were to choose a couple nicer coordinates here on this line, and I were to count the slopes, this one goes down 1, so it's a rise of -1 over 2, so -1 over 2. If I look at the second line, again, picking a couple coordinates here, the second line, from the left dot to the right dot here, it goes up 2 over 1. These slopes are not equal, but they do have a special relationship. I bet you can see it, or it's coming back to you now, how that worked last year when in geometry. So I would write this part down. If two lines are in fact parallel, then the slopes are always going to be equal. Whereas if two lines are perpendicular, then the slopes also have this special relationship where they are opposite. So opposite in sign, one positive, one negative, as well as reciprocal. You saw that in the 1/2 and the 2 over 1. So opposite and reciprocal. Sometimes this is referred to as negative reciprocals because one's positive and one's negative. Okay, let's take a look at an example of this. I'm given two lines. Are these lines parallel, perpendicular, or neither? Well, what we could do is get out a piece of graph paper, graph them, take a look, get a protractor out, see if we can measure, but there's some inaccuracy there. So instead, we should use the values or the numbers that were given and our slope formula. y2 minus y1 over x2 minus x1. And if we take each line separately here, so I'm just going to do line 1, and if I were to calculate the slope there, that would help me figure out its relationship to line 2. So in this line 1, y from the second point is 2. The formula says to subtract y from the first point. That's a 0. X from the second point is a -1. Subtract x from the first point, that's a 3. So if I calculate this, 2 subtract 0 is 2. -1 minus 3 more makes -4. 2 divided by -4 simplifies to make -1/2. So the slope of line 1 is -1/2. Let's do the same thing for line 2. Y from the second point minus y from the first point. X from the second point minus x from the first point. I'll simplify both the numerator and denominator here. 4 subtract 0 is 4. 3 subtract 1 is 2. 4 divided by 2 is 2, or 2 over 1. If you take a look at both of those, one is positive and one is negative. That's the opposite relationship. And they are reciprocal. So I can in fact say that these lines are perpendicular because I see the opposite reciprocal relationship. If you remember from geometry, the symbol for perpendicular is an upside down looking T. Okay, so thinking about lines and thinking about them crossing or not intersecting in terms of parallel and perpendicular, we should also remember a few things about linear equations. So we're going to take a look at some graphing, but before then that we need to understand what a linear equation is. I would again write this part down. A linear equation is an equation that uses x and y and also graphs into a straight line. You can see each of these equations has both an x and a y involved in it. Sometimes they just have to have x, sometimes they would just have to have y. But linear equations will have this sort of form. They'll use x and y. Now, a solution to a linear equation is a point, an x-coordinate, y-coordinate. So a point that works in the equation and makes it true. So here's an example here. Is the point 5, 4 a solution to this equation? Y equals 2x minus 6. To know if this is in fact a solution, I would plug it in to see if it works. In the point, the 5 is the x and the 4 is the y. So using that knowledge, I'll just take those values and plug them in where they belong here into this equation. So the y is a 4. There was a 2 in the equation. The x is a 5. And now what I have is an expression or an equation here with no variables. I need to figure out if this is in fact true. Well, if I calculate the right side, 2 times 5 makes 10. So it's 10 subtract 6, which is in fact 4. Just like the left side says it's supposed to be. So yes, this is a solution to the equation. But you know, there probably are more solutions to that equation. And so the graph of an equation is the collection of all the points whose coordinates are solutions to that equation. So the 5, 4 was just one piece, one solution of many. Okay, the x values are the domain and the y values are called the range. We're going to see the words domain and range come up quite a bit this year. So remember, 5, 4, the very first point we tried out here, 5, 4 was only one solution. There are more, like 3, 0. 2, -2. All of these points work. And as I keep putting points up here, what would they graph to make? Well, in fact, they would make a line. So when you draw a line, you're showing all the solutions that work in that equation. Okay, oftentimes when we graph a line, we're going to use what's called slope-intercept form. This is the one you most likely remember from last year in Algebra 1 as well. So a linear equation in the form y equals mx plus b is what's called slope-intercept form. Things to remember, m is the slope and b is the y-intercept. So really large in my notes, I would write y equals mx plus b and make a note to myself that m is always going to be that slope and b is going to be what's the y-intercept, so where the line crosses the y-axis. If you remember how to graph using this little setup or this little form, it's really quite easy to sketch the graph of a line without finding numerous points, okay? So it's the quick way to graph. So in this example, we're going to graph this using the y equals mx plus b, or slope-intercept form. You can see right now the equation that I was given is 3x plus 2y equals 4. This is not in y equals mx plus b form. It's not graph ready, as I like to call it, because the y is not by himself. In slope-intercept form, the y has to be isolated or by himself. So we need to do some moving here to get that y alone. So I'm going to subtract 3x from both sides of the equal sign. And now you can write 4 subtract 3x, or negative 3x plus 4, since that 4 was a positive 4. Okay, we're trying to make him look like y equals mx plus b form. There's still a 2 coefficient in front of the y, so we'll divide by 2. Now when you divide by 2, you need to divide everybody by 2. Y equals negative 3 divided by 2 is not a value that I actually want to calculate, and it's simplified as it is. This is my slope anyway, because he's in front of my x. So this I actually like as a fraction, because slope is rise over run. Okay, slope is a fraction, so I'm okay with leaving that as a fraction. 4 divided by 2, however, can be simplified into just 2. So here is my y equals mx plus b form. The y is alone. Now when I look at this, we need to identify 2 key things. 2 is the y-intercept. Okay, he's going to be the point we plot first when we graph. After that, we're going to perform this slope, because the slope is the m. The m is the coefficient in front of the x. And remember that slope is rise over run. So first things first, we're going to start with this y-intercept. So on the y-axis now, remember that is the vertical, we're going to put our first mark at 2. So in your notebooks, your composition notebooks have graph lines on them. If you bought a graphing composition notebook, you can go ahead and just sketch a little x and y axes and number them out a few places and just put your first dot at 2. Okay, this is the y-intercept. That's one key part of my line. The other key part of my line is the slope. So from this dot that we just made, I am now going to perform that slope. That slope says you need to go down 3, 1, 2, 3, then over 2 to the right to make a new dot. These 2 points will allow me to sketch my line. You actually probably want to hit your second dot there. I did not. Okay, make sure that you place arrows on either end, because lines do go on and on forever. They are not segments, so they do continue on through our coordinate plane. So that is a quick review of slope as well as graphing. Thank you very much.